Okay, good afternoon, class 10 students. How are you? Are you fine? Okay, you are fine, you are doing well. And today is 25th of Baisakh 2077. And today we are going to complete the lesson. The first chapter, that is force. Okay, we are going to complete the chapter force. So in today's class, we will be discussing at first about mass, weight, differences between mass and weight, and gravitational field intensity, free fall, and weightlessness. So let me share the screen that we are going to discuss today. Okay? Are you ready? So I'm going to share the screen. It is in CAM scanner. I have already scanned it. Class 10 PDF. This is a class 10 PDF. Friday is here, new class 10 PDF. Let me see which one is it. So it is being coming here. I think it was yesterday's one. So let me check whether it is there or not. So I'm sharing the screen, right? I'm sharing the screen. The screen what is given. CAM scanner 3rd, 6th, 9, 10, 9, 10 SE PDF. So Thursday, Wednesday. So where is it? So this is a class 9's, class 10's. Class 10 PDF. 1 minute, okay, 1 minute, just a minute. I'm checking whether it is here or not. Without sharing the screen, it will be quite difficult. It is taking some time to come. I will explain the things today. So let me check. Class 10. 10 only it is kept. This is the thing. I think it is not shared what. I'll check it here. Share. Word I have just done. So this sharing, it takes time. Do you know what is mass? How do you define mass? Students, you can say about mass. So mass is the quantity of matter contained in a body. Mass is the quantity of matter contained in a body. So what is used to measure mass? The device that is used to measure mass is physical balance, or we can say beam balance. Beam balance or physical balance. And the SI unit of mass is Newton, right? SI unit of mass is Newton, is it? It's not the one. Okay. Can you hear? Also, can you hear? Also, can you hear or not?
Yes, sir.
Okay, today everybody is hearing, so I'm just checking whether it is here or not. So I have just made. Okay, students. Now we will begin our lesson. Can you see on the screen? Mass. Definition is the amount of matter contained in a body is called mass of that body. How much matter is present in it? And we have already discussed matter is anything that has mass and volume. So they are interconnected. So total quantity of matter present in a body is mass. And mass is scalar quantity. Means it has value, no direction. And we use physical balance or beam balance or pan balance. You can write any. But nowadays people they use a bit advanced type of balance. What is it? Digital balance. You might have seen it. Digital balance. So the digital balance shows the digit, how much gram, how much kg, right? So the SI unit of mass is kg, and other units are quintal, ton, gram, centigram, milligram, etc. And students, you know, gold is measured in tola. If you talk about in Nepal, it is measured in tola. But you must know how much gram is there in 1 tola. There is 11.664 gram in 1 tola. 11.664 gram in 1 tola. I don't know how much grams of golden ornaments you are using. That is the next thing. So students, earlier we discussed about gravity. Could you remember what is gravity? Gravity is the force with which a heavenly body pulls an object towards its center, and weight of a body can be defined as the force with which it is attracted towards the center of a planet. The force with which it is attracted towards the center of a planet is called weight. Or we can say weight is the product of two things. What are they? Mass of the body, acceleration due to gravity. So weight is the force applied by a heavenly body to pull an object towards its center. And keep in your mind, weight and gravity are always equal. Formula is same, value also will be same. Okay students, I said physical balance is used to measure the mass. Then what is used to measure the weight? Spring balance. See, look at here the diagram of spring balance. In spring balance, there is one pointer. When any object like stone is kept or hung on it, the pointer goes slightly below and shows the value. Now tell me, which formula you are going to use to calculate the weight? W equals to m times g, mass times acceleration due to gravity. Dear students, the value of weight changes from place to place in Nepal. Means the value of G is more in Tarai and less in mountain region. Yesterday we discussed the value of G is inversely proportional to altitude. That's why we know the value of z is more in Tarai because distance is short, and the value of z is less in mountain region because the distance is more or altitude is more. So the value of weight of a body is more at polar region because the value of z is more, and less at equatorial region because the value of z is less. Okay, let's discuss about differences between mass and weight. To show the differences between them, we need to make very clear-cut table. So generally you have to remember 2 points. Let's discuss here. In first point, we can give their definitions. Mass is the amount of matter contained in a body. How much matter is present in it? Weight is the force with which a body is attracted towards the center of a planet or satellite. The force applied to pull that object towards the center is called weight. The value of mass of a body is constant. It does not change from one place to another. And the value of weight of a body changes from one place to another. Not only that, the mass of a body remains same in everywhere in the universe, but the weight of a body changes from place to place. Like if you talk about weight of a body in Earth, it is of one value. In Moon, another value. Weight differs. I mean, if Ram's mass is 60 kg on Earth, his mass will be same 60 kg on Moon. On Jupiter 60 kg, no change. But weight differs. In Earth, weight is 9.8 times more than its mass. On Moon, weight is 1.67 times more than its mass. And on Jupiter, the weight is 25.14 times more than its mass. It goes like that. That is the relation also. Just remember, mass is constant, weight is variable. Next point of difference is mass is scalar quantity, weight is vector quantity. Mass is measured by physical balance and weight is measured by spring balance. So 4 different points are given. You can remember any 2, but you have to write the correct one. Okay students, now here is one thing to discuss. Do you know? In this do you know, you have to discuss 2 things. What are they? Number 1 is gravitational field intensity. Gravitational field intensity, and next one is gravitational field. 2 things: gravitational field intensity and gravitational field. Okay students, first of all let's discuss. In class 9, there was one chapter, could you remember? The chapter was electricity and magnetism. Electricity and magnetism. Around a magnet there is one region. Around a magnet there is one region up to which the attractive force of magnet can be experienced. The space around a magnet up to which its magnetic force can be experienced is called magnetic field. Remember, that is magnetic field. But now gravitational field. What is gravitational field? The space or region around a heavenly body over which it can exert gravitational force on other masses is called the gravitational field. Or the region or space around a heavenly body up to which its force of attraction can be felt is called gravitational field. Gravitational field. But as the distance increases, the gravitational force becomes weaker, we know, isn't it? So if you talk about the earth, around the earth there is one region up to where its force can be experienced, around the moon also, around the Jupiter also. So in every heavenly body there is gravitational field. If an object reaches near to it, it is pulled towards the center, otherwise it cannot be. Suppose an object is kept in that gravitational field. An object is kept in gravitational field whose mass is 1 kg. An object of mass 1 kg is kept in the gravitational field and it experiences some force that is called gravitational field intensity. Let's define here gravitational field intensity. The force experienced by unit mass placed at a point in the gravitational field intensity, gravitational field of a heavenly body. Let me repeat once again. The force experienced by unit mass placed at a point in the gravitational field of a heavenly body is called gravitational field intensity. Make your concept clear? Space around the heavenly body is gravitational field. Force experienced by 1 kg mass which is kept in gravitational field of any heavenly body is gravitational field intensity. One is region, another is force. What is the formula to calculate gravitational field intensity? I equals to F by m. What is F? Gravitational force. What is m? Mass of the body. Dear students, now we will be discussing next thing, that is free fall. What is next? Free fall. Students, listen now. Earlier we discussed about air resistance. Now also let's repeat these things. When we drop an object from certain height on the earth, will there be production of acceleration? Definitely acceleration is produced. And because of production of acceleration, because of gravity of the earth, the body falls down. But does it fall without any problem? Does it fall without any resistance? No, it does not fall without any resistance. Why? Because there is air in the earth. So air tries to push it upward. It resists, blocks the speed. But if we do same thing on the moon, if we drop a stone on the moon from certain height, then it will fall without any resistance. So there is difference of falling of stone on earth and on moon. Now let's discuss the definition of free fall. What is the definition? When a body is falling freely towards the center of the earth under the influence of gravitational pull of the earth, the motion of a body is called free fall. A body is falling without any air resistance. That condition is called, that falling is called free fall. My dear students, in free fall, acceleration due to gravity of heavenly body and acceleration produced on that body is always equal. So acceleration of the body is equal to acceleration due to gravity of heavenly body. So free fall is possible in vacuum, remember, or in space. Why? Because there is no any resistance, any blockage. Now here you have to keep in mind, free fall is a type of motion on a body which is moving under the influence of gravity. There is no any resistance, nothing to block the object, just falls down. Here we have to remember, when a body is falling freely, there is no reaction force, nobody is blocking it, nothing is blocking it. Students, now listen. The next heading, weightlessness. We know weight is the product of mass and acceleration due to gravity. I said earlier, mass is always constant. It cannot be zero. But what can be zero? Weight can be zero. How? Weight can be zero because if there is no value of acceleration due to gravity, if the value of acceleration due to gravity becomes zero, at that time weight becomes zero. Then, if the weight is zero, there is mass but weight is zero. That condition is called weightlessness. Very interesting. What is the definition? The condition of a body at which where the weight of a body, apparent weight of a body becomes how much? Zero, is called weightlessness. Presence of mass, but the value of acceleration due to gravity is zero. So it is called weightlessness. So there are some conditions for weightlessness. Where can weightlessness be experienced? It can be experienced when a body is falling freely. It can be experienced when the acceleration produced on a body is equal to acceleration due to gravity of heavenly body. Second condition is when a body is at the earth's center or in the space at null point. At the center of the earth, center of the heavenly body, the value of weight becomes zero, so that condition is weightlessness. And there are some points in the space where the mutual force of attraction between two heavenly bodies is equal and opposite. That point is called null point. At null point, the value of G is zero. Object experiences weightlessness. And if any object is kept inside artificial satellite, the object's weight becomes zero. So these are the three conditions. One is during free fall. Second is at the center of the earth or at null point. Next one is inside the artificial satellites. Now, where can we feel weightlessness? So it can be felt I already said inside artificial satellite and in the elevator or in the lift. If the lift is moving down with acceleration equal to acceleration due to gravity, at that time we can feel weight zero or weightlessness. Students, now here we have to discuss two types of forces: centripetal force and centrifugal force. Centripetal force and centrifugal force. What is centripetal force? Centripetal force is the force of gravity of the earth on the spaceship. Remember once again, the force of gravity of the earth on the spaceship or any object or artificial satellite is centripetal, and the force which takes the body away from the center of the earth is called centrifugal. The force which is against the gravity is centrifugal. The force which is towards the gravity, that is centripetal. And for artificial satellite, centripetal force and centrifugal force, they are balanced. That's why it neither goes towards the center of the earth nor goes away from it. So it is kept in a point from which it revolves around the orbit. Around the earth on its fixed orbit. So here we have to remember, inside the artificial satellite also, the body becomes weightless. We can experience weightlessness. My dear students, now let's discuss next thing. Falling off a parachute. Okay, so in some events, Nepal army personnel just show some actions by jumping down from helicopter with parachute, and they land safely. We have noticed, isn't it? In some movies also we have seen some people, what do? They just jump down using parachute, and at the beginning the parachute is closed, and later on when the person jumps down, it opens automatically. Why does it open? Because of air resistance, presence of air on the earth. Then after opening of the parachute, the person or the paratrooper, we can say, moves slowly, because the area of parachute is more and air resistance is high, and his acceleration is reduced greatly, and he can balance the body easily and land safely without any problem on the earth. What if same activity is done on the moon? Like a person jumps using parachute, then what will happen? The parachute does not open. Why? Because there is no air resistance, and his acceleration is equal to acceleration due to gravity of the heavenly body or moon, and he falls down very fast and gets hurt. These things you have to remember. So, on the earth, falling with parachute is safe. On the moon, falling with parachute is not safe. These things you have to keep in mind. Okay, my dear students, so in today's class, we have discussed about, once again let's repeat, mass, weight, differences between mass and weight, gravitational field intensity, gravitational field, free fall, weightlessness, conditions for weightlessness, and falling of parachute on the earth and on the moon. Okay students, are you ready? Now what you have to do? You have to write these questions and later on make attractive question answer copy. I am saying the questions now. You write down the answers in very simple way. Many times I have said, now also I will say, questions are always easy, answers are really difficult. Questions are easy, answers are difficult. So what you have to do? You have to make the answers easy so that the persons can find out your ability and give the marks. Question number 1. Define mass. What is used to measure it? Define mass. What is used to measure it? Mention its SI unit. Number 2. On which factors does mass of a body depend? On which factors does mass of a body depend? Next question. Define gravitational field and gravitational field intensity. Gravitational field and gravitational field intensity. Next question. Define weight. Mention its SI unit and write the device used to measure it. Define weight, write its SI unit and mention the device used to measure it. Next question. Differentiate between mass and weight. Differentiate between mass and weight. Okay, next question. What is free fall? What is free fall? Write the condition for it. Next question. Define weightlessness. Mention any 3 conditions of it. Define weightlessness. Mention any 3 conditions of it. Next question. Why does an artificial satellite revolve around the earth? Why does an artificial satellite revolve around the earth? Next point. Differentiate between centripetal and centrifugal force. Centripetal, 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 CENTRIFUGAL, centrifugal, centripetal and centrifugal force. The last question for today is write the difference between falling of a parachute on the earth and on the moon. Falling of a parachute on the earth and on the moon. Okay, dear students. So today's class is over. We are in lockdown. It's continuing, but your study is not lockdown. Your study is going smoothly. So one chapter is nearly over, and in tomorrow's class, we will be discussing about the question answers of the chapter 4, and then we will move towards next chapter. So very soon we'll be having our classes inside the classroom. Nowadays we are having these online classes. So you need to be focused and do your best. Today this much. Thank you. Have a great day.